Blazor in .NET 8 with Daniel Roth.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a full-service software architecture and engineering firm that empowers software delivery for business-critical projects. And they've been a sponsor for quite a while, and they're hiring architects and engineers. So just go find clearmeasure.com and check that out. Quick announcement, my architect forums are still going strong and signups for the next session are up. And so if you lead a software team and if you're looking to collaborate with other peers in the industry who are leading software engineering teams, then go ahead and sign up at the link in the show notes. And of course, for those looking for Programming with Palermo, my video show, just search for it in any of the directories and you'll be able to find it. My guest today on the show, returning again, is Daniel Roth. And he's a principal product manager on the ASP.NET team, working on ASP.NET Core, Blazor, and other web features. And he's previously worked on various parts of .NET, including System.NET, WCF, XAML, ASP.NET, and all its forms. And his passions include building frameworks for modern web that are simple and easy to use. Daniel, welcome back to the show. How are you, sir?
Hi, Jeff. It's great to be back. I'm doing great. How are you?
Fantastic. Couldn't be better. And for those who kind of watched all the content, .NET Conf just before Thanksgiving, they saw your fingerprints all over it. But for those who missed it, or maybe just kind of stumbling upon this and don't know how instrumental you are with all of that, kind of rewind a little bit. I always like to ask the formative moments in your career that kind of landed you working in the framework area that kind of enables so much programming that all kinds of developers do all over the world. How did you get there? Like, what happened?
I don't know. I keep pinching myself every morning that I get to do this. It is a great job. I work with a lot of amazing people, by the way. I don't know how much credit I really deserve for all the wonderful things that shipped. Just this past week at .NET Conf, .NET 8 just went out. A whole bunch of new exciting features in Blazor. But of course, a lot of other really neat announcements as well. .NET Aspire for cloud native development. How did I get to here? I joined Microsoft a while ago now, fresh out of college, actually. And I've always worked on .NET. I've mostly worked on the backend server technologies, networking, did some, like you mentioned, some WCF stuff. Like that's a flash from my past. More recently, I've mostly been working on web and ASP.NET. I remember when I think it was Scott Hunter when he pulled me into a room and was like, Dan, we're gonna take parts of .NET and we're gonna make it open source. And that was like, whoa, what's happening? Back then it was just .NET Framework. Everything was just part of Windows and closed source. And so I got to go through that part of the .NET journey and been working on web frameworks ever since. There was that wonderful moment when I got to work with Steve Sanderson. So that's been a cool coincidence. We got brought together and he did a really awesome demo at, I think it was NDC Oslo in 2017, 2018 or whatever it was, where he was showing how you could use WebAssembly to do cool things in a browser. And he ran some .NET code in a browser and built this little web framework called Blazor. And got a bunch of people excited, and we then worked together to try and convince our management that should become a thing. And I got a chance to work on Blazor with Steve, and that's what I've been doing most recently for the past few years. It's just been a journey working on .NET and trying to make developers' lives easier when building particularly server-based technologies, although now a little bit more on the client with Blazor WebAssembly and a little bit on Maui as well with the Blazor hybrid support.
I want to ask about all of that, but you mentioned, okay, right out of college, come over to Microsoft. And so on behalf of everyone listening that's really early in their career, of course, a common question is, what does the career paths look like? And what's next? I got hired to be a coder somewhere, but what could my career look like? At internal IT departments, you typically have the developers, and maybe you have an architect that talks to people outside the development team. But at Microsoft and other companies that build and sell software products, you have kind of some more roles. What are the common career paths? Because there's probably your peers who are just full-time software engineers that literally write code all day long, every day, whereas you go to conferences and talk to other people. And so it's kind of a different job. What are the just a handful of different types of roles at a company that sells software products?
Oh man, I mean, there's so many, so many people that are involved in getting the software out the door. I mean, obviously there's the actual software engineers, like the people that write the code, and their management chains, and they don't just write code, like they also are doing the testing and quality assurance and the build ops and the documentation, like they work on the docs for the stuff that we ship. They do a ton of stuff to make the product happen. When I came out of college, like I studied computer science, I thought I was going to go and become a software engineer, be a professional programmer as my main career path. And then when I was applying for jobs at Microsoft, I learned about this role. At that point, it was called program management. It wasn't a product management. That name kind of shifted more recently. But I found that it had this nice blend of being involved with what the software needed to do, like figuring out like what the software needed to be, as well as aspects of the business side, like understanding what are customers' requirements, like what are their scenarios, like how are they going to use the product, what features should we prioritize, and it created this nice blend of working not only on creating cool software, but also getting exposed to the realities of selling software, making a business out of making that software available. And that really appealed to me. So that's the role I slotted into. Originally was program management, and now more recently we call them product managers. I think that's the more standard. Yeah. But there's lots of other people, like architects, people that deal with some of the meatier design problems involved with building the software that we ship. The folks on marketing that help people understand what is this stuff that we ship. Yeah. We have community teams that engage with folks in the open source world, and members of the .NET community that use our products and give us feedback. There's just a ton of the doc writers themselves that help the engineering team with getting writing good English so that our docs are intelligible. I think there's lots of opportunities, and it takes they say it takes a village, right, to raise a child. It certainly takes a big team to ship good software.
Well, I think of the skill sets that your product manager position has, and certainly other software type vendors. I think of companies like Infragistics or Redgate or Octopus Deploy. They're selling technology products, and they kind of have those same needs where the product manager has to have some really good software architecture skills, as opposed to say a product manager of a non-technical company. Yeah. Right. And if you went a product manager in working on .NET was this perfect marriage of getting exposed to API design and building software and what it's like to build software. That my product is the thing that developers use to write software. Right. So I get my hands dirty with that, and I still get to write code as part of my day job. But at the same time, also getting exposed to that more business aspect. What is the actual value to the proposition for the customer? What problems do they have, and how can we turn that into features and prioritize our backlog appropriately? All those types of problems, doing those both together is really, I think, what has worked well for me in this particular role at Microsoft. Other product managers on different teams might not have as much of that. Like if you're a product manager on Office, you're probably more involved in like what is the productivity scenarios that my users need to have solved, like what kind of user experience in these tools should we be building. You probably care a little bit less about what's happening under the hood in terms of code and engineering specifics. By being a product manager on .NET, I get to do a little of both. That's right. Yeah, if you're a product manager on Excel, you're probably really good at math.
Addition and subtraction. I have a lot of respect for accountants. I've often found that that kind of math is some of the most hard math to get right. It's so easy to lose some numbers along the way when you're doing all these like giant spreadsheets of modeling and accounting for things. So yeah, right. I imagine so.
All right. Well, a lot of stuff in Blazor that's coming out. Tell me if I'm overstating it. Just kind of overall vision, overall strategy, and what's ended up happening. Do you agree with my assertion that with .NET 8, Blazor is the new, quote, normal .NET project type?
I don't think there's anything normal about Blazor. It's like, it's fantastic.
It's the new normal.
It is I think if I were coming to .NET and I wanted to build a new web app, and you asked me, Dan, like, what should I use to build my web app? Without hesitation, I would say you should use Blazor. Blazor is going to be your best bet, because it now handles all of your web UI needs. No matter what kind of web app you want to build, you'll be able to do it with Blazor. Whether you're trying to do things from the server with server-side rendering, or you want to do things from the client in the browser with client-side rendering, running on WebAssembly, having some code that runs on the user machine, and a bunch of click stops in between. Like we've enabled all these progressive enhancements that can take your server-side rendering-based UI and enhance it in various ways with a little bit of code from the client so that things are smoother, so they load faster. Blazor can do all of that with a single reusable component model. Within one application model, you can handle server and client and everything in between. And I think that's what's really powerful about what's new in .NET 8. In the past, Blazor was just about the client, really, right? Like, you could do .NET on the server, but if you wanted to do anything in the browser, that meant writing JavaScript, and Blazor gave you a way of doing something with C# instead of having to write JavaScript to fill that client-side gap. But in .NET 8, Blazor really has now extended to support the full spectrum, full stack of web UI scenarios, everything from server-side rendering all the way down to the client.
Well, and you're saying web, but I mean, when I think of the new normal, I mean, the Maui team is given, their first session at .NET Conf on Maui talked about Blazor.
Yeah.
and what about WPF? So, I mean, this isn't just web. Tell me if I'm overstating, but it seems like it's the new normal.
You can do native client as well. You can do, it's really it still is web, right? Like you're using the web stack HTML for your UI rendering. You're using a browser control embedded in a native client application, but you get all the native client capabilities married with the web by using that hybrid pattern. That Blazor hybrid pattern is what we call it. So yeah, you can use Blazor also for native mobile and native desktop application development as well, using the same programming model that you would use for your server-based web apps or client-based web applications. Yeah, it extends to all of your web UI needs across the board. And I mean, that really speaks, I think, to the power of the web platform. Like the web platform really has this broad reach, like it goes everywhere. And by using .NET to target the web platform, you get the strengths of both. You get that reach combined with all the performance and the security and the productivity of using the .NET platform for development.
Yeah, I had a team that needed a simple system tray application. And so they did it with Blazor Native and a little WPF shell because they needed to integrate with Windows 11 Action Center. So they needed some of those APIs, little icon in the system tray, but the few little pop-up screens that every system tray program needs, it was a few small Blazor screens. So because their developers like, do we really have to figure out how this XAML thing works? Because none of them had used XAML before, but they're like, no, we don't.
That's right. Yeah. And you can then use that same component that they use in that system tray app. If they wanted to use it elsewhere, the component code doesn't need to change. It's just C#, HTML, and CSS fundamentally. And so it can run anywhere that you can run .NET code and the web platform.
So let's catch people up, because you and I talked last year. For people who didn't make that show, we'll put a link in the show notes. But you had the server-side Blazor come out first. Some WebAssembly debugger wasn't on the first version. So I think there's a group of developers who kind of looked at it and said, okay, some things are not ready yet, and they've been on the sidelines. So for people who kind of have been watching from afar, what now is like first class? Nope, we got everything put together. Maybe a few rough edges when it first came out, but what things like run like a dream now that maybe in the first version, admittedly, okay, wasn't quite ready yet?
Well, first of all, in prior to .NET 8, if you wanted to build a Blazor app, you were immediately presented with this choice. Well, what kind of Blazor app do you want to build? Do you want to build a Blazor server app, which was a way to run Blazor components from a server environment that then drove the web UI experience in the browser over a connection? Like we set up a WebSocket connection between the browser and the server, and we could handle all the UI interactions over that connection. So you got the rich interactivity of like a JavaScript-based single-page app, but it was all actually being driven from the server using your .NET code. That was a Blazor server app. Or you could build a Blazor WebAssembly app where you downloaded the .NET code to the browser along with a small WebAssembly-based .NET runtime and just ran your component code right there on the user's machine. So you had these two models, and you had to pick which one you were going to use up front. Like they were separate project templates.
Yeah.
And people would, often need guidance and would fret over this decision. Like, well, which one should I use? Should I do Blazor server? Should I do Blazor WebAssembly? They have different trade-offs. In .NET 8, you just build a Blazor web app. You just build a Blazor web app, and it can do it all. You then decide on a per component basis or a per page basis how you want that component to run. Do you want it to just run kind of like a traditional old school web app, like from the server, where it receives a request, generates some HTML, and sends it down to the client, and then it wipes its hands and says, I'm done with that? That's like static server-side rendering, the type of rendering we've been doing for years with frameworks like MVC and Razor Pages, or non.NET frameworks like Ruby and PHP. You can do that now with a Blazor component in .NET 8. Do you want some interactivity? Do you want that component to now be able to handle button clicks and those types of things? Well, then you can just change the render mode of the component and say, you know what, you're now an interactive server component. Or alternatively, you're an interactive WebAssembly component. And so you can now handle all the UI events that the browser can send at you, and I'm deciding you'll run from the server, or I'll decide you run from the client. And you can have different components in the same app that run from the server and other ones that run from the client, depending on what makes sense for that part of the UI. And then when you are done with that interactive component, like maybe you just have one page in your app that really needs that interactivity, then you don't need to pay the cost of that interactivity anymore. You can close the connection if you're doing it from the server and free up those server resources, and then continue doing normal static server-side rendering and with great scale characteristics. Or if you were running on WebAssembly, well, you've downloaded the WebAssembly runtime to cache it so that you could run the component initially, and then if you have another component later that needs the runtime, well, guess what? It's already there and set up for you. Even better, you can actually decide which render mode you want the component to use at runtime. You can start off a component using interactive server rendering, like it renders over that connection with the browser, and that loads really fast because there's very little that needs to be downloaded. You can just set up the WebSocket connection and you're good to go. But then simultaneously, in parallel, you download and cache the WebAssembly runtime in the background and cache it in the browser. And then for future renders of that component, you can say, oh, do I have a WebAssembly runtime already here for .NET? Oh, I do. Well, I'll just run this component now on the client and not even need any of those server resources to run that component. I've offloaded that work down to the browser. We call that the new auto render mode, where it automatically decides at runtime which of the interactive render modes to use based on whether the .NET WebAssembly runtime has already been downloaded and cached for you. So it gives you the best of both worlds. You get the fast startup time of a Blazor server style application, but then the cost characteristics, the scale characteristics of a Blazor WebAssembly app by moving the code down to the client. So all of that is now possible within this one model. You just build a Blazor web app, and then decide what you want different parts of your app to do, how you want them to run by determining the render mode.
the render modes are really interesting. You guys internally have had all kinds of philosophical and what if and how are people going to use this going forward. All the JavaScript SPA frameworks, I think everybody's used to being on a slow connection on Facebook or YouTube where it pulls up the initial page really quickly. Oh, but it's just like animated gray boxes that are just placeholders. And it's like, oh, okay, we're waiting for all this other stuff to load.
JavaScript bundle to come down across the network.
So for all these JavaScript sites, and of course, lots of .NET developers have built JavaScript on top of .NET APIs. Whether it's bringing back a JavaScript bundle or bringing down a .NET assembly, it's the same thing. It's like I got to wait for something. Wait for something more to load so I can execute it on the client side. And so, given that those patterns have laid out, what's the opinion of you and your team? Should the development world kind of 80% of the time just kind of use those tried and true, hey, please wait, here's an animated box? Or do you think that 80% of the time this auto start from the server and then move over to the client is more appropriate? I know it's a philosophical question and it's a guess, but I'm just curious at what those internal conversations have yielded.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
I don't think it's really a philosophical question. Like I'll put my product manager hat on and say, I think it's really an end user scenario, like requirements question. Like what do you want the experience for your users to be? What would be the best experience for your web application, given what you're trying to deliver? In many scenarios, I think having them wait for a JavaScript bundle to download in order to see the app is probably not what you want your users to experience. You want them to see the app as fast as you possibly can, and leveraging the server to optimize that user experience makes total sense. And in fact, a lot of the existing front-end JavaScript frameworks have already realized this and have already done a bunch of work for precisely this reason. Like if you look at frameworks like React or Vue or Angular, a lot of them have already added features that enable you to now render their components from the server for precisely this reason. The zero JavaScript bundle size scenario for like Next.js, which is effectively React, but with some of these server-side rendering capabilities. That's what's motivating, I think, that progression of features is, well, we want to deliver the best experience for our users. Sometimes that means delivering content directly from the server in response to the request and not having them wait until we can actually wire up client-side rendering. Now, does that mean that every single app should be written that way? No, I don't think so. Like, are there scenarios where it makes sense to do things purely from the client side? Yeah, like maybe you have an offline scenario and you want the app to be able to be downloaded and cached, and then if your network's gone because you're out like in the middle of a farm field or some remote place and you need the app to still work and then sync up later, like a client-side model for that app makes total sense. It really depends on what user experience you're trying to deliver, and then picking the architecture and the features that make the most sense for that user experience. We think there's room for all of them. That's why we have gone pretty broad with Blazor and enabling as many of these application patterns that we think make sense. I know a lot of people like to get into the SPA versus server-side rendering debate and argue like which one's better. And I think that's probably missing the point. Like they both really have a place. You should use the right tool for the right job. Yeah.
Well, the server. I think of all these blog sites where, for a while, you think, oh, let me do a blog site or an article site in Blazor. It's like, well, how quick, if someone clicks on a link on a search engine, how quick is just showing an article going to happen? You know, if it's server side, well, now we made a really expensive blog site from an Azure bill perspective. And then if it's Blazor, if it's a WebAssembly, well, now we just slowed it down. Just because they're just going to read the article and bounce.
Server side rendering, then it's just a request reply. You get the content and you're good to go. I mean, you get the full power of the ASP.NET Core request reply handling pipeline now in your favor. So now it can be very fast. So you have that option. I don't think there's very few scenarios now that I could think of where where Blazor would not be a good fit. Like, it has enough flexibility that I think it can adjust to pretty much any web scenario that you'd want to do. Right.
Well, and you mentioned the auto. Well, I'm thinking, don't we now have that same scenario? It's like you can start on a URL, or you can then upload to all of that wrapped in an iPhone app or an Android app.
Sure. Yeah.
Not automatically, but
as wrapped as like a PWA, or do you mean like wrapped as a
well, now we have
hybrid-based application?
We have fully URL launched rich applications. Of course, it can detect, hey, am I running inside the iPhone app? No, I'm not. Hey, let me suggest that you can get me from the Apple Store or the Play Store, and maybe they install the app and keep going, or they can just keep going, straight from a URL launch,
straight from the web perspective. Yeah, absolutely.
Yeah, cool. Now, for the developers who've built some really cool stuff with the server side version, they're used to having a minimal amount of layers. Maybe they have Blazor components talking to another class. Then they're talking to some entity framework code. Then they're hopping over to Azure SQL. In order to enable auto, they've got to insert a web services layer in between there to get that to work, right?
Yeah, that's true. That is true. Auto does come with some added complexity in terms of how your app works. Your components, to some extent, this was already true with Blazor. Like, when you did Blazor WebAssembly in the past, we didn't set this up for you by default, but you had the option of pre-rendering your components from the server just to get some pixels on the screen fast while you set up interactivity with the .NET WebAssembly runtime. And if you did that, well, then your component might run on the server, and then later will run on the client. And so you had to design your components to handle both cases. And then that's actually our guidance. Like, we recommend that when you build a Blazor component, as much as possible, try to think about building that component in a way that's agnostic to where it's eventually going to run, whether it's running from the server or from the client or from a hybrid application. Ideally, that component should be shielded from those concerns. And you do that by creating services with interfaces that you have different implementations for those interface based on different environments. Like, maybe if you're on the server and you need to get some data, well, you can just talk to the database. And so you have an get weather forecast data service that you inject that knows how to just use EF Core to get the data, or make an API call to an actual, proper weather API. Whereas when you're on the client, then you need to do a slightly different pattern for getting that data. Maybe you're going to be bouncing through an API layer on your origin server. And so you inject a different service implementation for that interface into that component that will work in client environments. Obviously, designing your components that way does add a little bit of complexity. It's often just easy to assume, well, I'm always going to run on the server, so I'm just going to write code that assumes I'm in the server environment. But that will limit your components' flexibility. If you write your components in this agnostic way, then you can shift them around without as much impact on your broader application. But you're absolutely right. Like, auto does require you to be able to write components that can run on both server and client, and that may mean standing up API endpoints for them to talk to for getting data and all those types of things.
I think that's a big idea. That's a really important point that I want to highlight for everyone listening, because so many people I've talked to over the past years have said, you know what, we're going to go Blazor server side because it's easier for our developers, or it's faster, or it's less that I have to do, because they don't have to write the web services. And I think what you said is important. It's to maximize your choices in the future for that application. You should go through web services in order to get to any other backend. Don't just assume that it's running on a server natively that happens to be in the same data center with all of your backend dependencies.
I mean, it's a good habit to get into, good pattern to learn to develop with. I mean, I want to give allowance for developers that know that they have an app that's just very purpose built for one thing, and they know it's always going to run from the server, and it's always only needs to handle maybe a couple hundred concurrent users or whatever it is. And you got to get the job done sometimes, right? And I understand that you don't always need to architect for every future scenario with every single application, but it is a good practice. It will set you, if you do need that level of flexibility in the future, you will be grateful that you have set yourself up for success that way.
Well, then let me ask you about the Azure bill, because I think it was about a year ago, so it's probably updated, but we interviewed Stefan Shakow, who's one of the architects on Azure App Service, and I'd asked him about Blazor, and he said, well, we think that P1 v3 is probably the smallest instance size that you want to go at for a Blazor server-side application because of the memory. And so if we do even have a small departmental application, do you have any, like on your side, any guidance for the smallest instance size if it's going to be hosting a Blazor server-side application?
As far as I know, like you should be able to run on any server instance side that you want, as long as it's going to have enough resources to handle the number of concurrent users that you care about handling. Blazor server, remember, it's a connected model, so you're going to be paying with your server side resources for every user that comes to your app. Like every button click, it's going to have to run some .NET code on your server to handle that button click. And so you need to think about, given n, I expect 100 concurrent users or a dozen concurrent users or 10,000 concurrent users, and then you need to think through, for each user, what's really going to happen on the server? Am I going to load up like 100 megabytes of memory and crunch on some data for every single user? Or is it like much less load than that? And that's what you need to think about when you figure out which server instance size you will need to handle that load. A long time ago, like when we first shipped Blazor server, back in .NET Core 3.0, we did some scalability testing, and I forget it wasn't a big VM, like it was a sort of a normal size VM. And I don't remember the exact SKU that we picked. I have to go back to the blog post and dig up the data. But we benchmarked like how many concurrent users at its foundational level that Blazor could handle. And I think it was like 20,000 concurrent users on just one VM. Blazor could handle without really any issue. So that gives you kind of a feel for what Blazor server's like baseline scale out characteristics are. Like obviously you'll build your app on top of that and you'll start consuming server resources with your application code. And so that number will start to drop as you start allocating memory. We did find that memory utilization seemed to be the main bottleneck. It was like how much memory you got and how much memory do you need for each user was what seemed to matter most. Obviously, that could change for your app. Like maybe you just have a very CPU heavy workload and you're doing a lot of compute for each user. Then you'll have to worry more about the compute resources available on the machine. But for our test, memory seemed to be dominant. And so that's really what you'll need to think about and do some tests. For a lot of smaller like internal line of business apps, like Blazor server is so convenient. It's so easy. And I think that's why a lot of people really like it. It is still the most popular choice for Blazor when we look at our numbers on like how many people are using the different application models. It's also convenient not just because of being able to access server resources, but because it's fundamentally a stateful programming model. Like you have stuff just sitting in memory and you can just assume it's still going to be there, which is different. And this is, I think, surprises some people when they start looking at some of the new .NET 8 features. Like if you start doing static server-side rendering, more like the traditional MVC patterns or Razor Pages pattern, request reply. Now you're back to a stateless model where the state on the server is only going to normally survive as long as the request lives. So if you've gotten used to that Blazor server model where like, my component instance is just there and I've got a field in memory and I can just keep adding to that dictionary and read stuff out of it. Great, this is so nice. And then you switch to the request reply model and you get a request, your component instance gets created and then it's gone after the response is sent. That can surprise some people who've gotten hooked on that stateful programming model. So to be aware of that, you'll if you use the static server-side rendering patterns, you do need to start thinking again, like if I have any state that needs to survive across requests, you're going to use the normal tool set for doing that, like sessions or sticking stuff into Redis caches and so forth.
Yeah.
Persisting things into local storage on the client and whatnot.
And you mentioned hygiene. It's just a good idea anyway. I would assert that it's just a good idea to offload that state anyway, because let's say you got a small application and the second you add a second app service instance, well, now you have that state's only on one of the servers now.
Yeah. Moving state around does become a problem. Like you have to use sticky sessions, like with your load balancer in a Blazor server-based app normally, so that if anything needs to reconnect, it ends up back on the same server instance where your we call it the circuit state for that user was being maintained. You get the improved scale-out characteristics when you move to the stateless model. This is why a lot of people for a long time have been preaching, you should really make your web apps stateless. If you have any plans in the future to scale up to lots and lots of users. And that is, I think that is still good guidance. But, again, allowances. Like if you're just building a small app and you just have, a very specific task for a very specific audience inside of your company or whatever, then a Blazor server app is still a perfectly fine solution.
Right. Well, I'm looking at the Azure pricing calculator, and I think the standard S1 has 1.75 gigs of RAM, and then the premium P0 has 4 gigs of RAM. It's very different. I know I personally ran on P0 V3 plenty for just like, a dozen users, and they don't really notice anything. It just works fine. But yeah, minimizing the bill, I think, is important for a lot of just regular IT department teams, Well,
then
they get a budget.
If you're trying to reduce on COGS, like starting to push things off the server starts looking really appealing, right? Like there's that user's machine, which has a CPU and memory that's just given to you for free, effectively, right? So start looking at moving some of your more intensive components down to the client onto WebAssembly.
So before we kind of end, what other big Blazor news really needs to be highlighted for everybody who didn't watch all the .NET Conf sessions?
Yeah, sure. So we didn't just do traditional static server-side rendering in .NET 8. In addition to being able to render your components from the server, we added all these progressive enhancements. Like we have what we call enhanced navigation and also form handling, where when you're navigating from page to page in a Blazor web app, Blazor can intercept those page navigations, do the request for you, get the response. It's still doing, server-side rendering. It's still just getting up HTML from the server, but then it can intelligently patch those that new HTML into the DOM for you, preserving a lot of the existing DOM state and making the page navigation much smoother and faster. Very similar pattern with form handling. Like if you do a form post, Blazor can intercept that, get the returned rendered HTML and patch that into the DOM. So like if you're just getting some validation errors that you just want to show on the screen, you get that SPA-like feel for an app that is still just doing server-side rendering, traditional server-side rendering, no WebSockets involved at all. By adding this just a little bit of, it's effectively a little bit of JavaScript that Blazor is giving to you as part of the new blazor.web.js framework script. Also streaming rendering, like there's common patterns where you have a page that's going to render from the server and you need to go get some data, like make an API call, do a database query, and it might take a little while, and you want to get pixels on the screen fast. So with streaming rendering, you can render the component initially with a placeholder, like loading ... or whatever, with the main layout of the page already nicely rendered. And then once the async tasks complete for getting that data, Blazor will render that component again for you automatically. And then a new batch of HTML can go down on the same response stream that from the original request. Like again, no WebSocket connections, no WebAssembly, just another batch of HTML that Blazor can then patch into the DOM for you. So you can stream updates from the server as these long-running async tasks complete. So your user gets a nice, smooth, fast initial load plus automatically applied updates as they come streamed in. And then we just added a whole bunch of other just general framework improvements, like Quick Grid is our built-in data grid component that we previewed with .NET 7. It's now available and stable with .NET 8. We added support for sections, so you can specify outlets for content in one component that can then get filled in from a completely different component. It's very similar to sections in MVC and Razor pages, if you've ever used those frameworks, like in CSH, except now done with components. We made a bunch of improvements to the router and a lot of authentication improvements as well. We now have a full Blazor implementation of the default identity UI that you can use to set up authentication, login, password reset, registering users, 2FA, all the features that ASP.NET Core Identity supports. That in the past we gave you a Razor Pages based UI in order to interface with. We now have a full set of Blazor components that you can use for handling all your authentication and identity concerns. So quite a bit. Like this was a big release for Blazor and .NET 8. We're pretty excited about it. We're not done. There's lots more coming in the future. We're just kicking off our .NET 9 planning now, talking about what we're going to do for Blazor, and the future I think is pretty bright.
You mentioned identity. That's a huge one. Like how many small applications or even big applications where all the users are employees of the same company? And by the way, that company already has Microsoft 365. They're already logging in, with Microsoft identities just for regular old stuff anyway. And as an application developer, I'm saying, I don't want to mess with this. I mean, they're already logging into other things. Can I just have that Microsoft identity just log into mine too? And now it's just kind of automatic, isn't it?
Yeah, I mean, I definitely I think you're talking about like using like Azure Active Directory, or like I think it's Microsoft. What's it? Microsoft Entra now is what they rebranded themselves to.
Or the same identity. If I log into Microsoft Teams, like
the hosted identity providers that are really great. Like you offload all of your identity concerns to these services, and they know how to, like with the Azure ones, they know how to integrate with your organizational accounts, and you can really easily log in users into your web application that way. In that situation, usually the identity UI is handled by the service itself. They provide the login screen, and you're just like redirecting people, like go over there, talk to Azure, talk to Microsoft Entra, log in with your Microsoft 365 account or whatever, and then I'll get a token, like a JOT token with some claims that let me know who you are, and then I'm good to go. We also provide, though, in ASP.NET Core, a full identity solution that you can, deploy yourself with your own application. Like if you want to own the user passwords and identities for your users directly in your application, that's what ASP.NET Core Identity is for, and it now has a full Blazor UI that you can use with it to fully customize and handle as part of the application.
Okay, so this is a total replacement of the previous login, reset password screens that came with it.
It is a Blazor-based implementation in addition, actually, to we still have the Razor Pages one. So if you're an MVC developer or a Razor Pages developer and you still want to use those technologies, those are absolutely supported in .NET 8 and will continue to be supported. So that's still there. But what's new is the new Blazor-based implementation of the identity UI, so that you can write all of your UI, including the identity concerns, using Blazor components.
Okay, gotcha. We could go on for another hour talking about all this, all this stuff. But I appreciate you coming back on the show and sharing with us Blazor and .NET 8 and all the new goodness.
It's my pleasure. If you haven't tried it out yet, I encourage you to go to blazor.net. Just click the Get Started button, and you can build your first Blazor web app in just a few minutes. It's one of the things that we really work hard to optimize for with Blazor, is that fast, productive developer experience. Get from zero to a running app and a full, productive development environment really, really quickly. So yeah, go to blazor.net, and you can try out Blazor in .NET 8 today.
Very, very cool. Awesome. We will wrap it up, and thanks again, Daniel.
Thanks for having me, Jeff.
All right. My pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, Thanks for listening, and may God bless you.